Awesome. Hi, 9 a.m., dreadful hour. All right, introduction to type classes. So hopefully everybody that is here waiting to get the definition what a type class is. So I have information for you guys. There's not going to be one. I decided actually to tell you a story. It's going to be a story about a blackout, and it's going to be in 4 acts. So act number 1, loss and grief. Meet Jim. Jim is a senior developer doing some hacking, let's say in Poland. And he's a senior developer because he's been ever since he read this book. Now, life for Jim is very happy. You know, he earns a lot of money, he's doing software he likes, he thinks he's doing actually high-quality software. He is a cool dude. But one day, a dreadful thing happens. Stack Overflow, his main resource of software development and inspiration, dies. The same goes with Google. And now, Jim is a little bit scared. So, current psychology, modern psychology, tells there's 5 stages to a loss and grief. 1 is denial. This thing didn't happen. The other one be anger. How could that happen? How can it not be working? Then there's going to be bargain, like, if I only could save the questions about how to actually reverse a list. There's the depression. I'm never going to be a software developer ever again. And our last stage is going to be an acceptance. Okay, I have to actually deliver that software. Let's try to do it. So this is Jim trying to figure out how to do that without Stack Overflow or Google. Act number 2, the mess. So Jimmy is working for this application, which is basically an auction application, which is like an eBay. But we have 2016, so it has to end with .fi and have the domain .io. But essentially, it's the same thing. Now, I've never worked for any of those domains, so I've made an example. Maybe if something is from the company like those, maybe they might be laughing. But for the sake, for example, let's just imagine that the domain is like this. We have some orders, and the orders may be general, which contains a list of products, a complex, which will just wrap a list of more orders, and one will be canceled, which basically means that somebody ordered something, but it's not ordered anymore. And there's a list of products, which basically is the same thing. So we have an item and price on a basic product. We have a discounted product which wraps a current product and gives a discount. And there's an instant which says out of stock. So we used to have a product, but it's no longer available on the shelves. And there's a list of features that Jimmy has to provide. So it's Monday, and he starts doing it. So the first feature would be calculate the final checkout for the order. And Jimmy writes a test, which basically says, So this is, Jimmy creates a domain. So this is exactly the same thing that we saw. So we have an order, and some general order, cancel order, and a complex one, and same goes for product. The same thing that we saw a moment ago on the graphs. And then Jimmy creates a test. So we have like a general order, another one, a canceled one. He creates complex one based on the list of previously created. And he calls the method evaluate and expects some results. Now, how Jimmy can implement this feature? You have to remember that Jimmy is now a senior developer, but he used to be a junior developer. And when he was a junior developer, he was constantly being beaten up with one book. And when I'm saying constantly, I'm saying like waking up 3 a.m. in the morning and that book, immediately in front of his eyes. So Jimmy learned to solve every single problem that he encounters with one of the patterns in that book. One of those would be Subtype Polymorphism. And so he goes. So he adds to those domain objects a method, evaluate. And if anything is going to be in a gray colorish here, just think of it as not really that important in that presentation. It's only here for the sake of the completeness of example. So essentially, we have an evaluate method in the trait evaluatable, and now every object, every order implements that method. So a cancel implements it, complex order implements it, and so a general order. The same thing goes with product. So product also implements that trait, and so on has to provide implementation for this method evaluate for basic product, discounted product, and out of stock. And the test passes, and Jimmy's happy. Well, actually, this isn't that bad. I might survive this outrage, this problem with Stack Overflow. So, first feature done. Let's create another one. So, Jimmy needs to calculate the average price of a list of orders. So, he creates one more time test. So, there's an order, a second one, and a third one. He creates a list, calls average, and gets some kind of result. The test fails, and so you have to provide the implementation. Now, there's no Stack Overflow. So you cannot no longer type how to calculate average. You have to go to the math books. And so Jimmy does it, and he actually gets this. And he's pretty much happy, so all you have to do is provide the implementation. So he will map over the order list, evaluate it, and then call mean method on some kind of statistic object that he created. He's ready to commit, but then comes Jack, because Jack overheard when he was actually doing some coffee in the kitchen that Jimmy is providing this library for statistics. And he's happy because he has the same problem, only not for big decimals, but for integers and for doubles. And he's like, oh, awesome, can you do it? But can you make it more generic so I could use it as well? Thanks. And so the Jimmy is stuck with a more general problem. He now has to provide something more generic for the other guys to use in the company. Now, if only we had in Scala some trait, like a number, that we could put it here and it would just work, right? We could be an integer, double, or big decimal. Unfortunately, no such trait exists. So now Jimmy has a problem, but as again, he always can find a solution for any problem using that book. And he finds one which is called adapter. So he creates a trait number, which will have like methods like divide and plus and value, and he creates adapters for every other type that he needs. So there's a implementation for big decimals, there's an implementation for integers, and implementation for doubles, and so on. For any type that he has, he can create an adapter. And now all he has to do at this point is make that statistic method, the mean method, more generic, taking this number, the adapter, and provide implementation. The thing is, as you guys know, the above code will compile. However, now this thing won't. So what Jimmy has to do is wrap the evaluated value, which is a big decimal, into the adapter. Having that, he will have to return a big decimal. So at the very end, he has to call the value method. And now the whole thing compiles and it works. But now Jimmy realized, and he knows and he sees, there's a lot of boilerplate happening. The main part is this and that. There's a lot of boilerplate happening, and he sees that any more complex calculations than average are going to create a more like a messy code, and he's not happy. So the tests are passing, but now Jimmy feels something is not wrong. Something is, I'm moving away from a cool and pure code. I'm not going the right direction. But anyway, features has to be implemented, so he moves to another feature, which will be present current state of orders in JSON. All right, so he creates a test, which is basically he makes a list of orders. He has expected JSON to be serialized from the list from the final order, and he calls a JSON serializer write method with an order, and expecting that JSON he just created in tests. That test failed, and now he has to provide implementation. One more time, he remembers there's things like converters and stuff like that, so he creates an object serializer that will take he was actually going to just create this implementation of a simple order and make a string, but there's Kate, and Kate also overheard the rumor spread out pretty quickly that Jimmy is creating libraries for the office right now since Google is not working. So she's like, yeah, can you make a library out of it and make it more generic? Thanks. So now Jimmy is screwed and have to create something more generic. So he creates a JSON serializer, serializable trait, which will, essentially the idea is that any class that will implement that trait will have to provide method to JSON, which will provide an object JSON value, and that JSON value will be understood by a JSON writer. So JSON writer takes a JSON value object, and if anything needs to be serialized, it actually has to implement that trait, and this will essentially work. So let's try to create that. So there's some case classes for JSON value. Hopefully nothing surprising. There's implementation of the JSON writer, and I provide that implementation for completeness, but it doesn't really matter at this point. Just imagine there's a method that will take anything of type JSON value and creates into a string that is a proper JSON. So let's just leave that detail out of the slides. And now we have a trait that will anything that needs to implement that trait will give us this method to JSON, and we have a JSON serializer that will serialize it to a string. So now Jimmy can add to order. He had a trait evaluatable. Now he can add another trait, JSON serializable. So near the method evaluate, he creates a new method to JSON with the implementation, and that goes to every other object that he has in his domain. So every domain object has that method to JSON, to JSON, to JSON. And the test is passing, the thing is working. But yeah, we can cross that out. But now Jimmy feels something went wrong. He feels kind of dirty, you know? He's like, something is not right. Because he remembers this comic, The Life of Software Engineer, clean slate, solid foundation. This time I will build this thing right away. Oh God, I did it again, haven't I? And he has the same notion. Why? Because if we think about what Jimmy created, if you really think about it, the goals that his principal goals that he has to be highly decoupled and, you know, dry and whatever, are not here. We have a domain object. It has a business method evaluate. On the same level, it has a method to JSON, which are from two different abstractions, right? And even so, what does it mean to evaluate order? On one domain, an evaluate order might actually mean to calculate the value. But on the other domain, where somebody is dealing with complaints, evaluating an order may actually do something completely different. So now, I don't know if you guys had the experience, but essentially you might have a domain object that grows with numbers of different methods which have nothing to do. They have nothing in common, because between evaluating the value of the order and putting that into JSON, there's not really that much common in the sense of the code even that you're providing. So you now have a domain, an ability to save it to JSON, an ability to evaluate it, and now think of what will happen if suddenly you have a customer that will say, well, now I need to serialize it to JSON or XML. Then we will put yet another method on that domain object. So as I said, Jimmy felt kind of dirty, and he said, before I move on with any new feature, I just have to refactor that. And so goes the act number 3, reinventing the wheel. And now the happy part starts. So Jimmy, you want to go with the first example that he used, which was the second, which was the evaluating of the average value of orders. Just a reminder, it looks like this. So he had an adapter pattern, and so he thought that's awful. Why? Because essentially there's a lot of boilerplate here, and yeah, that's pretty much it. So he was thinking, I'll start with something easy. Probably that can be done a little bit better. More readable to the user, to the other developer that will be looking at that code. So he thought, like, essentially, what I wanted to have was this. This is what I ended up, because my method was supposed to be generic, because I had Jack, and Jack needs to have this implementation for doubles and integers. But my original idea was that. So when I had a statistic mean method, that would take just big decimals. But I cannot do this because I need to stay generic. Now the problem is, if I need to have that, then this will not compile. If I had just generic A type, my compiler doesn't know if A actually has a plus method or divide method. So Jimmy thought about it, and he just imagined, well, if I have a problem, what normally I do? I just push that up to some other guy to deal with it. And so he did. So he created, he said, like, let's create a trait, which we call a number, and that trait will actually know how to divide and how to sum two objects of that type A, whatever that type A might be. It might be an integer, might be double or big decimal. So somebody will provide me implementation of that trait that will actually know how to divide and add two things of type A. So that would be, the implementation would be something like that. So I take the number divided, I take the number plus, and it will work. So we need that trait with those methods, and now having that trait, we need to provide implementations. I will just try to strongly emphasize the word implementations, so instances. The instance for a big decimal is going to be looking like this. It's pretty similar to the adapter pattern. The only thing is that we don't wrap anymore any big decimal. We're just saying, if you have two types of big decimals, this is how you sum them, and this is how you divide them. And the same goes with integers and other types that you want to provide. Now, the cool part is, for this thing to work, we need to just provide, at this point, you see that we need to provide the implementation for big decimals, so we need to just do that. But since we had this implicit argument, and we can provide a big decimal number into implicit scope, this thing might disappear. So we are getting towards something. Now, the only thing is that this part of code over here above, I would argue it looks kind of, sucky. I would say it could be that the previous implementation with just symbol plus and divide was a lot more readable. So we can do another thing. We can actually add one more object, which would be we would use an implicit conversion. So we say, whenever you have something of type A, and we had that number for that A in implicit scope, then add 3 methods to it, plus operator plus and operation division. And having that imported into the scope, into implicit scope, we can now change our code to look exactly like this. I don't know if you guys see it, but this number operation, this is implicit conversion that converts our object of type A into number ops. It wraps it up, adding a few more operators that we can use on that object A. And now Jimmy ends up with something like this, which is the title of this presentation, having a cake and eating it too. Why? Because what we get from the client perspective, from the user of that library, we sort of see that that library was actually created for big decimals, right? We don't see any magic happening here. It's just I provide big decimals and it simply just works. But on the other side, on the side of the library as well, we also can provide very readable code that works with any type A, because we provide a plus and division for the type, regardless of what that type might be. It might be actually a string, or a user, or maybe an order, or whatever. And the tests are passing, and Jimmy is happy. Now he feels we can move this with this. So he goes with JSON. As you remember, JSON looks like this. So we have this writer, the value, and the serializer. And the implementation will be looking like this. So we have this implementation subtype polymorphism within the domain object. Now Jimmy thinks, what I can do to make it better. So instead of providing that JSON serializer, what he will do is he wanna create this JSON value out of any object A. So we want to have an object of type A, whatever that A might be, and he wants to make it into a JSON. So we will do exactly the same thing as we did with numbers. So I don't know at this point how to change A into JSON, because I don't know anything about A. It might be double, it might be string, it might be a user, it might be an order. But since I don't know how to change that into JSON, I will take as a parameter somebody who does. So it's going to be a JSON trait. It's going to be a JSON trait that will know how to change any object of type A to a JSON value. And I can provide that guy as a parameter to that method. And it's going to be exactly the same thing as we did before. So for that JSON trait, we're going to provide 2 instances, and I'm going to strongly emphasize the word instance, to that JSON type. One for product, which we're going to say how to change a product into JSON value, and one for order. And I'm leaving the examples as the whole code for completeness, but it really doesn't matter. The point is that everything that you see over here used to be a part of that small method inside the domain object. Just copy pasting from domain to this one object over here. And same goes with product. Essentially, it doesn't matter how it works. What matters is that we have 2 domain objects, and we pushed into some explicitly dedicated place how those things are going to be converted to JSON value. So now the only thing that we have to do is provide those guys who are, as you can see, implicit. All we have to do is provide them into implicit scope, and the whole thing will magically work. Now Jim is in the flow. I'm going to do it eventually to the very end. He has only an evaluate method. Now he remembers that evaluate for him meant actually calculating the value of the order, but somebody was talking about evaluation, which means something completely different. So he imagined, could I actually move the evaluate method as well? And he can do the exactly same thing. So this is how the code looks before. Now all he has to do is provide yet another trait that will evaluate anything of type A to some value T. whatever that A and T might be. So all now Jimmy has to do is provide implementation instances of that trait. So there will be one for product, what does it mean to actually evaluate product? And there will be one for order. What does it mean to evaluate order, right? So now, when we had that implementation order and we called evaluate over here, this method from order we just deleted, right? We deleted from the main object. We pushed all that into those objects over here. We taken that method over here to different place. So this thing will not compile. But we can make one more time this trick with implicit conversion. So we are saying whenever you have something of that type A, and you know how to evaluate it into value T, then provide a method to that type A, which will be evaluate, and we get this, and this thing compiles. And now Jimmy is happy because everything basically works. What he ends up with is this domain that he has, which is clean because it corresponds directly to the domain that he had described by the client. He had implementations for variety of features that he was providing, which were from different abstractions. One would be the evaluate order, and the other one would be converted to JSON, which probably this one is used on the presentation layer, and this may be somewhere on the back end, right? All that was being moved to different places. Now, if anyone is here like really towards the object-oriented world, he might say, now this actually sucks, right? Because now if you have a new order or new product, in the previous example, all you had to do was basically create a new instance of a trait order, implement all the methods like evaluate and to product and stuff like that, and everything would work. But I would say there's no such thing as a golden hammer, because I can give you a counter example. Imagine that you are adding a new type of your domain. You're not creating an order, but now all you have to do is create a new feature. So let's say serialize it to XML. In previous implementations, you had to go through all and every object of the domain and provide to XML method to it in order for it to work, and your domains would just grow and grow with every feature happening. But now you can push all that feature into one single place where it will know how to serialize itself, any type, to XML. Now, the other one might argue is that, okay, but this sucks, because I've learned, when I was learning how to do software development, is that whenever you do pattern matching at this point, you are exposing your domain. You're just saying like how everything looks inside. I've learned that you're supposed to have like an object which will hold the state, and nobody will be able to mess around with it. However, if we keep that immutable in a functional way, if we keep that structure immutable, we don't care if anyone sees how the structure is actually inside. The only pro that we get from hiding a state with an object in the object-oriented world was that nobody could mess around with our internals of our object. So no threads would create different things and weird things might happen. Here, we might be very transparent of the structure. And if you think about it, how many times your structure actually changes comparing to the functionality? So how many times you add a new domain object and how many times you create a new feature? How many times an existing feature means something completely different? It used to mean something, but now it means something completely different. So think about what is your case and when you want to go with one approach or the other. With that, we get a clear domain with a functionality which is spread out into a specific places. If you want to know how to evaluate an order, you just go to one specific file and you read the implementation. Now Jimmy is in the flow. He wants to create a new method. Unfortunately, he has only 30 minutes. And fortunately, the Google and Stack Overflow are back. And so we get the act number 4, which is called enlightenment. And Jimmy is going to do what he was supposed to be doing when he was in the university, but nobody told him, actually research. So he learned that the thing that he actually created, that we actually saw, the number trait, the JSON trait, the evaluatable trait, All that were type classes. All that was a type class as a definition. And ability to add those features to an existing type, so you had an order, which is was a simple structure, like anemic domain, you might say. Ability to add that evaluate method, or to JSON method, or whatever, is something that we call ad hoc polymorphism. And that structure that we saw here, somewhere here, where we have a simple domain without any methods in it, is something that we call abstract data type. So abstract data type, by definition, is just ability to describe that domain, and the functionalities are in a separate place. So having four more minutes, I will just wrap it up with two important things. First one would be a type class. Think of a type class as ability to extend your existing type, whatever that is, string, integer, use, and order, with any method that you need. So you, for example, want to some types to have an ability to serialize to JSON. So you create a type class, JSON, with a method to JSON, all right? And if any type, whatever that type might be, string, list, order, want to be part of that type class, you need to provide an instance of that type class. So ability to implement that train. And then, whenever you have some method that takes that type class, that JSON type class as an implicit parameter of any type A, you can provide the instance of that type class, and you have the ability to serialize it into JSON. And we reach that. So where to go next? Like, if you wonder ever what is a monad and stuff like that, all of those guys are actually type classes. So they're just saying if a type something option want to be a monad, then are those two methods that need to be implemented, and there are just some laws guarding that method, and that's basically it. There are some links, especially on this one is important, how to create an avatar from South Park. Before we go to questions, there's one bonus, because I have 3 minutes, so I can actually use that bonus. So remember how we had a type class number, and we had some operations. Now, in Scala, you get actually a nicer convention to have the same thing, which looks like this. So those two are exactly the same thing. Here we are taking a sequence of type A, and we are taking a number. We are taking a number type class that will know how to divide and add two things of type A together. We can actually use that notation. Instead of this, use that. And I found that more readable, because that is simply, for me, that is saying that I have something of type A right here, which will be provided with an instance of a type number. So I read it as a type A extended with functionalities from a type class number. Now, the problem might be when we have something like that. So we used to have that JSON over here type class, but we actually used it. We call a method on it. So if we one more time use that approach when we are saying type A is extended with a JSON, and we need to have ability to actually call it, there's a method implicitly over here that allows us to take a reference to that instance of provided instance of a type class. Essentially, this is just a semantic sugar. So this is the same thing. Just if anyone is confused, this is essentially the same thing. It will compile to the same thing. For me, it's just a lot more readable just to say, I have a type A, and A is whatever, but whatever that A might be, it also needs to know how to serialize itself to JSON. All right, folks. My name is Paweł Szulc. This is my Twitter. If you have any complaints, just tweet. You suck. This is my blog, where I actually started blogging, so please look it up. And the code that you saw is actually on my GitHub. And thank you very much.